Okay, so this is just a quick intro to the project for AScii Art. This document is on Firefly, so you can look at that whenever you want to. I've just tried to split it up and think about how I might go about doing the program. So in task one, it asks us to create a menu system. So creating the actual menu, not a big problem. You might decide to do that as a separate definition so that you can run the menu whenever you want to. That's probably the way that I would look at doing it. I've drawn a system overview or a bit of a decomposition for this as well. So we've got the menu at the top. And this menu is going to need these options. And then obviously if you wanted to take this decomposition on further, then underneath this sort of box for entering RLE, you're going to have several other things to do. And the same applies to converting and displaying and possibly quit as well. It might be that you've got extra things to do with the menu. So obviously one thing to do with that menu is to display it. Another thing, you need to get the user's choice, so whether they've chosen 1, 2, 3, 4, or 5, and then somehow handle that choice as well. So handling the choice is going to be running some of these items that you will have programmed to do that. So all I've done is go through some of the tasks and just say what I think I might need to find out about. So task 2 is making the quit option. And you might need to research, how do we exit a Python program to do that. I think for me, I'd write a separate procedure again to handle the quit option. Of course, you don't have to, but I think I would. And it would be quite good if the user was able to make a choice of whether to quit or not. So when you click on the quit option, it might say, are you sure you want to quit? I identified that I could do an if statement for that, or a loop and an if statement in order to keep looping until they give us a proper answer. Task 3 is entering RLE. So again, I need to get some input from the user. So I'm going to need something to store that in, a variable to store this input, and how many lines I'm going to input. So it asks you to put the number of lines in. So mostly this program runs as a set of lines. So when I did this program, I took the approach of thinking about a line of the ASCII, and then thinking that if I could do one line, then I could use that exactly the same code over and over to do all of the lines. So I'm going to need a variable to store the input of how many lines, and I'm going to need to use loops to ensure that I'm entering all the data for the number of lines, so and that it's more than 2. So you have to put more than 2 in. So I'm going to have some validation there with a loop. So some validation looping there too. And I'm obviously going to use another loop to decide on to get the data from the user. So they may well be different types of loops. So this one, second part, task 4, we need to be able to load a text file for this. So something you might want to research into loading text files if you've not done it much before. There's lots of stuff on Firefly for it. You might choose to search for that elsewhere if you do that usually for Python, but there's definitely stuff on Firefly to help you with text files. And there's a number of ways that you can load text from a file as well, which would be worth experimenting a bit with. So you're going to need some user input with the name of the file. So when I did this, I added .txt onto the end, that being the file extension for text files, because most people don't actually put the .txt thing in when they're adding their file name. So I just added that on by concatenating or sticking together that string with the name of the file. And so that's, you've got to load the file up and just basically show it. So you've got to show that file for displaying. Converting, this is probably a bit more tricky to do. You can see that we've got the run length encoded data, O1 comma and O1A and O1D, etc. And we've got to convert that file into the actual picture. So doing the conversion is probably a bit more tricky. So you've got to be able to enter a file name again, load the file that contains the data, and then read in the data and decompress it. So the way that I looked at doing that, I worked in lines. So I read a line of the file and then converted that line and added it onto a new file, a new string basically. So I was making up a new text string based upon the values in here. Now the thing you've got to watch out for, some of these are O1, some of them are 5, 7, etc. So the first two characters that you're looking at are going to be a number, but you might need to think about how you're going to process that 0 and make sure that that's processed okay. So you're going to have to read those two characters, and then the next character, in the case of the first bit, which was a comma, is what we actually want to reproduce. And when I got 57, 57 eighths, and I want to reproduce 8 57 times. So obviously we're going to need to, when we do that, we're going to need a loop. So again, we're going to do some looping in order for me to put 57 of those next to each other perhaps. And we're going to have to read through this line of data. So as I say here, I'm going to need to step through the line of data, and I'm going to have to read each character. I know that the first two characters I read out of every 3 are going to be a number showing me how many times to do something, and the third character is going to be the character I'm going to repeat. So all the stuff we did on string manipulation is really useful there. So you can choose 3 characters from a string. That's really handy for this program, and there's lots of stuff on Firefly for that. There's for you to look at again. So manipulating strings and taking characters from that string is really useful thing to be able to do. The last task is converting RLE. So there's a supplied file which looks like this. The option takes the ASCII art image and converts it to a compressed data file. So in order to do that conversion, I'm going to need to be able to count the number of consecutive characters, including the spaces here, where I've got a line there with almost all spaces. I'm going to need to be able to count those and then reproduce those as a file that looks like this one with a set of numbers, etc. So again, you might decide that we're going to work as a string, because we are going to work as a string, even though these things are numbers ultimately, because when we need to go O1, if that's a string, it's going to preserve O1. As you know, if that's an integer, O1 will just become 1. And we don't want that. We want the actual O1 in there so that we can read 3 characters every time. So that's a little bit, again, of a little bit of a tricky thing to think about doing. Again, all we're doing is, when I did this, I processed a line. So I processed lines, processed 3 characters at a time in that line, etc., and wrote that back into another text file, and then ultimately saved that file. So I'm going to have to be able to read and write files, count how many characters are in each file. So the last thing you have to do is to say whether we've compressed the data or how much we've compressed the data. So how many characters were in the original file and how many are in the new file, and compare the two. So again, that's the last thing to do in this project. So that's just conclusion of introduction. So